2.9. We've got y bar is a over s, b over s squared plus c over 5. So we've got these three unknown coefficients. We put it back over s squared, s minus 5. And you're going to be looking at a times s minus 5 plus b times s minus 5. Distinguish your 5s and s's here. And lastly, c times s squared. So that's a quadratic on the top. Multiplying s squared, you've got a plus c. Multiplying s, you've got minus 5a plus b, don't you? And the only constant coefficient is minus 5 times b. So we compare coefficients of this numerator with the original one. So looking at the coefficients of powers of s in this numerator with the original one, which is this one up here. And we see that this implies that a plus c must equal 2, minus 5a plus b equals, so it's an s there, equals minus 3. And lastly, minus 5b equals minus 10. So we got our three equations for our three unknowns. Do Gaussian elimination, or because these are very simple, just unravel the solution. Solution there is saying that b is 2. And if b is 2, then minus 5a is minus 5, so a is 1. And if a is 1, then c is 1. That make sense? So we have this unknown function y bar now as 1 over s plus 2 over s squared plus 1 over s minus 5. Now this is ready now to take inverse transforms. Okay. So we take an inverse Laplace transform. So we say y of t is the inverse transform of y bar. And we can use the linearity of the inverse transform here. So this is the inverse transform of 1 over s plus 2 times the inverse transform of 1 over s squared plus the inverse transform of 1 over s minus 5. That's by linearity. And then just reading results off the table. The inverse transform of 1 over s is just the constant 1. 1 over s squared is the transform of the function t. And 1 over s minus 5 is the transform of e to the 5t. So that means we found half the solution there. Y is 1 plus 2t plus e to the power 5t. But we still have the function x to find. Now we got a couple of choices here for finding x. Either, I mean, by default, the one that will always work is return to equations for x bar and y bar and substitute in in y bar to get x bar equals, this will be a rational function of s. Okay, so you return to, where was it in the, return to those two equations there at the top of the page. We know what y bar is now as a function of s. You just simply bung it in to either of those equations, and then you've got an equation for x bar. Then partial fractions and inverse Laplace to get x of t equals whatever it is, function of t. Or we can notice here, one of the ODEs is quite simple in terms of x. So either do that or we can do this. Notice that ODE in equation, so it's 2.39, that equation back in the notes, it's quite simple in terms of x because it just mentions x, 3 times x, and dy, dt, and y. But you see, we've got y of t here, and there's going to be no trouble at all to work out y of t and dy, dt. So that was dy dt plus 3x plus y equals 2t. Well, dy dt now I can notice is 2 plus 5e to the 5t. And this is 3 times x plus y is 1 plus 2t plus e to the 5t. And this is all equal to 2t. And this is that's straightforward to solve for x because x is the only unknown quantity there. So that implies that x of t is going to be a 1 over 3 times, so constants, you've got a 3 on the left, so it's going to be a minus 3 on the right. Vectors. You've got 2t here, there's a 2t there, so they're going to cancel. Then you just have the exponential, so 5e to the 5t, so you've got 6e to the 5t, so stick it over, it's minus 6e to the 5t. So that's minus 1 minus 2e to the 5t, seems to be. Yep. So that gets us to it rather quicker than that first option. But that's only because one of these ODEs was quite simple in terms of x, in that it didn't feature any derivatives of x. So if that quick path or quick route isn't available, you would just have to default back to this one, which in principle will always be this. Okay. Or if there was more than 2 equations, you know, you'd have a family of more than 2 equations here in the x bar, y bar, z bar, say. You just keep returning to these, keep picking off a new function by process of elimination, solution, so on, partial fractions, inverse transform, and so on. Okay, that finishes us for this afternoon. So I'll be back here at 5. Depending on how many, I don't know if you are not. I've got some other examples of this kind of thing from past exam papers, so I'm going to do some of those this afternoon. But I'll put the output from it up on Moodle afterwards as well.